Assalamu alaikum students. Today our topic is related nuclear energy. What is nuclear? Nuclear energy is simply the energy obtained from the from the conversion of nuclear mass. Within the nuclear there is proton, neutron. That very mass energy obtained from the conversion of nuclear mass is known as nuclear energy and energy. But this very nuclear energy that we are obtaining is obtained by two processes. There are two processes. This nuclear energy is obtained by two processes. What are the two processes? One is known as nuclear fission, which we are going to discuss right now, a bit of it, nuclear fission. And another is the second process, which is known as what? Nuclear fusion. Nuclear fusion. So what is nuclear fission? Nuclear fission simply means the splitting of heavy nucleus. Nuclear fission is the process in which a heavy nucleus is splitted. So nuclear fission, the process in which heavy, by heavy we mean which is having a large number of huge number of proton and neutron. The process in which heavy nucleus is splitted into lighter ones along with the release of large amount of energy. Now, this very process was first started by Strassmann and Otto Hahn. What they did, they took uranium 92-235 is a heavy nucleus because it's having a huge number of protons, that's 92, and 1 is 235 minus 92, you will get the number of neutrons. So as you are aware that heavy nuclei as well as very light nuclei, those are very much unstable, but the intermediate nuclei are very much stable. So this very heavy nuclei, once it is bombarded with a thermal neutron, this is neutron, by thermal neutron is having energy of the order of 0.025 electron volt. This is known as thermal neutron. When this very, because neutron doesn't have any type of charge, so it is going to penetrate deep. Once this very thermal neutron is bombarded on this very uranium, what happens? It gets, there can be two processes in this very fission. There can be two processes, as within the nucleus there are two forces. One is the nuclear force which tries to maintain the spherical shape of nucleus, and another is the electrostatic repulsion force which tries to destroy the spherical shape of the nucleus. Once this very thermal neutron is bombarded on the uranium 92-235, there can be two processes. One is there can be radiative capture. What do you mean by radiative capture? This very neutron is absorbed and it will become as 92-235, 236. Sorry, 230, because this very neutron is absorbed, and this very process is known as radiative capture. Why this happens? This happens because within the nucleus there are two types of energies. One is the nuclear energy, another is the electrostatic energy. When it is bombarded with the thermal neutron, it is captured by the nucleus. That very nucleus, that very absorbed neutron provides an excitation energy to the nucleus. So there is an excitation energy. If that very excitation energy is large enough, then if it favors the Columbus repulsion force, then there will be splitting because Columbus repulsion force wants to destroy the ship. But if it is not that very much large enough so that it cannot destroy the shape, then the nucleus will remain in the spherical shape, and there is a bit of excitation, and that excitation is evolved in the form of gamma rays. So once the neutron is simply absorbed, this very neutron doesn't provide that very much excitation energy which favors what? Electrostatic repulsion force. Then there is no splitting, there is simply radiative capture, as the excitation energy is not so much high. uh, that is why the nucleus keeps its spherical shape, and that very process is known as radiative capture. Now, on the other hand, if the nuclear neutron bombarded on the nucleus, if it provides a high excitation energy, which favors if excitation produced by thermal thermal neutron favors repulsive force. Then what happens? There is nuclear fission, there is splitting, there is splitting of what? There is splitting of nuclear. So what happens? Then this is a thermal neutron, it's going to bombard on uranium 92 235. It first becomes as uranium 92 236. Then this is that very much excitation that it is going to split it out. There will be splitting of this into lighter ones, and we will get a barium here. Barium is 56 141, and we will get here krypton, that is 3692, plus we will get 3 neutrons, and plus we will get 200 million electron volt energy. So there is conversion of mass into energy. That very energy comes out to be in the form of 200 million electron volt. So what happens? There is that very energy is released per fission due to a mass defect of 0.215 AMU. There is a mass defect of 0.215 AMU. There is a small mass defect between the products as well as the reactants. So what happens actually in fission? Fission, first you have to understand, fission process takes place once this very thermal neutron produce excitation energy which favors which one? Repulsive force, which what's electrostatic Columbus force, because that is the repulsion one. And what happens then? There is the formation of intermediate nuclei. There is formation of barium, which is an intermediate. There is formation of krypton, which is intermediate nuclei, and which is having a binding energy per nucleon large as compared to uranium 92 to 36. This is having a large binding energy. This VD2 is having large binding energy per nucleon as compared to uranium. So on the basis of, once you might be aware, once we have read the fission, we have read the binding energy per nucleon, we read at that very time fission takes place because the reactants they are formed, they are having a large amount of binding energy as compared to the uranium 92 236. So there are the 3 thermal neutrons and there is 200 million electron volt. This energy comes out at the cost of mass defect, which is of the order of 0.215 AMU. So this was the knowledge regarding the nuclear fission. Tomorrow we will continue with the nuclear fission. We have to read about many more things about nuclear chain reaction, controlled or uncontrolled. That will be inshallah tomorrow. Till then, Allah Hafiz.